Welcome back to the deep dive. Today we're tackling something you hear, well, all the time in fitness circles.
Hmm.
This idea that doing too much training volume for muscle growth, beyond a certain point, it just becomes junk volume.
Right. The point of diminishing returns or even negative returns.
Exactly. And it often stems from this assumption that strength gains kind of hit a ceiling at pretty low volumes, maybe 5 sets a week or so.
Yeah. And people then extrapolate that thinking muscle growth must also stall out right there.
But is that really the whole story? That's what we're digging into today, this really fascinating and honestly often debated relationship between volume, hypertrophy, that's muscle growth, and of course, strength gains.
Absolutely. We've pulled together quite a bit of research here. We're talking meta-analyses, recent studies, really trying to challenge that common view.
Yeah, maybe find some surprises along the way.
I think we will. The goal here is to cut through some of the noise, clear up maybe some misconceptions.
And give you, our listeners, a much clearer evidence-based picture, so you can figure out what actually makes sense for your training.
Precisely. Help you make informed decisions.
Okay, so where do we kick this off? Let's start with that traditional view you mentioned, the one that's been so dominant.
Sounds good.
So let's lay out that common argument first. You mentioned those Pellin meta-regressions, big analyses, right?
Combining lots of studies.
And initially, they seem to show strength gains kind of petering out beyond, about 5 sets per muscle group per week?
That was the initial interpretation. Yeah, around that mark.
Which then led people to think, okay, the real growth, the contractile stuff, the myofibrillar hypertrophy that makes you stronger, that must also plateau there.
Right. Yeah. And any exercise people saw with higher volumes, that got dismissed.
Dismissed as what, like water weight or something?
Pretty much. Things like temporary muscle swelling, or maybe this other concept, sarcoplasmic hypertrophy growth of the non-contractile bits, basically not real strength-producing muscle.
Okay, but you hinted earlier that maybe this comparison isn't quite right.
Yeah, that's putting it mildly. The direct comparison between the strength results and the hypertrophy results in that Pellin paper, it's actually quite misleading.
Misleading. How so? I thought meta-analyses were supposed to give us the big picture. If the studies weren't the same, what's the issue?
Well, that is the issue. They weren't based on the same set of studies. It's a bit of an apples and oranges problem.
Okay, explain that.
So the strength analysis had like 66 studies, over 2,000 people. The hypertrophy one, only 35 studies, about 1,000 people.
Right, so fewer studies for hypertrophy.
And crucially, only 21 studies were actually in both analyses.
Ah, okay. So lots of studies were only in one or the other.
Exactly. And a whole bunch of those studies that were only in the strength analysis used untrained subjects.
Untrained people. Okay, why does that matter so much? They get stronger. Right.
They get
Yep.
stronger really fast, yeah.
Yeah.
But a huge chunk of that initial strength gain comes from neural adaptations. Basically, their brain and nerves just get much better at firing the muscles they already have.
Ah, so it's learning the movement, becoming more efficient. Not necessarily building bigger muscles, especially not at low volumes.
Precisely. And when you include all those studies with massive neural gains in the strength analysis, but not in the hypertrophy one, it really warps the picture. It makes it look like strength plateaus way earlier relative to volume than it might actually do if
Yeah.
you're just looking at muscle growth itself.
Okay, that makes sense. It's kind of muddied the waters by mixing beginners with experienced lifters. So what happens if we clean that up? If we look only at studies with trained people where they measured both strength and muscle size, does the story change?
Oh, absolutely. It changes significantly. When you isolate those studies, trained folks, measuring both things, like maybe squat strength and quad thickness, you get a very different pattern. We looked at data points from 5 such studies, covering 9 different strength measurements. The groups doing higher volume averaging around, say, 27 sets a week.
Okay, that's quite a bit.
Yeah, they gained more strength in 7 out of those 9 comparisons compared to the lower volume groups who were doing maybe 19 sets a week.
7 out of 9. That's pretty consistent. And muscle growth.
Even more consistent. More muscle growth in 8 out of 9 comparisons for the higher volume groups.
Wow.
And here's the kicker. The only times higher volume didn't lead to more strength or more growth. Those were in the few comparisons involving untrained lifters included in those specific studies.
So for trained people, the trend was clearly higher volume, more strength, more size.
Exactly. It directly contradicts that whole idea that strength gains stall out early, undermining that core low volume is enough argument, at least based on this line of reasoning.
Okay, that's really important clarification. But then why do some meta-analyses still seem to show strength benefits tapering off, even if muscle growth keeps going up with volume? Is there another factor?
There is, yeah. It's about training specificity. Think about it. Low volume training is often super focused. Heavy weights, maybe just one or two main lifts, very specific to building maximal strength in that lift.
Right, like powerlifting training.
Exactly.
Right.
Whereas higher volume training, it's often aiming for both strength and size.
Yeah.
So you might use a wider range of exercises, different rep ranges, maybe not always lifting maximally heavy on the main strength test exercise.
So it's less specific to hitting a huge one-rep max on that one lift the study measures.
Precisely. Which is fine. It's arguably more like how many people train in the real world ecologically valid, as we say. But in a meta-analysis comparing strength outcomes, that lower specificity can make the higher volume groups look slightly less effective for peak strength than they might actually be overall.
Gotcha. So it's not that high volume doesn't build strength, it's just that the way strength is often tested might favor the lower volume, more specific approach sometimes.
That's a good way to put it. It influences the results we see in these big analyses.
Okay, so we've tackled the data comparing strength and size gains directly, but let's go a level deeper. There's this underlying assumption about why muscles get stronger, right? The idea that it's all about the contractile proteins.
Yeah, the actin and myosin cross bridges. The common thinking is more cross bridges equals more force, end of story.
But you're saying maybe not the end of the story.
Definitely not. That premise, that strength capacity is solely down to the number of cross bridges, is actually false. There's more to it.
Like what? What else contributes to how strong a muscle actually is?
Well, a big one is connective tissue adaptations. These improve something called lateral force transmission.
Lateral force transmission. Okay, break that down.
Think of it like this. The muscle fibers generate force, right? But that force has to get transmitted outwards through the connective tissue layers surrounding the fibers and the whole muscle, eventually pulling on the tendon and bone.
Okay, like the force needs a pathway out.
Exactly. And resistance training strengthens that pathway. It increases specific proteins at the points where fibers attach to this connective tissue matrix. This directly makes the whole muscle better at transmitting force, independent of just the fibers getting bigger.
Huh. So the scaffolding gets stronger too.
Precisely. And this isn't some new, wild idea. Scientists were talking about this back in, like, 1989.
Wow.
And here's a potentially related, really cool idea. Challenging high-volume training might actually cause tiny, temporary unstickings to adhesions between the muscle fibers and their surrounding connective tissue.
That sounds bad, like damage.
Well, it might involve a protein called tenascin C, and it seems to be part of the repair and remodeling process. It might temporarily reduce strength capacity a tiny bit while things get rebuilt. But it's likely necessary for strengthening that extracellular matrix, the scaffolding, which ultimately allows the muscle to handle more stress and continue growing. So paradoxically, while your muscles are growing, they might also be undergoing these connective tissue upgrades that could cause temporary dips in strength capacity.
So strength isn't just size, it's also how well the whole structure works together, and improving that structure might involve temporary trade-offs. That's complex.
It is. It shows that the relationship isn't as simple as bigger, you'll always stronger right now.
This whole discussion, really highlights a bigger point about how we understand things in fitness and maybe science in general. This tension between, logical arguments and actual hard data.
Absolutely. It's kind of a classic philosophy of science thing, rationalism versus empiricism.
Explain that.
So rationalism is building arguments based on logic, premises, known mechanisms. A leads to B, B leads to C, therefore A leads to C. A lot of common fitness beliefs are built this way. They sound logical.
Okay. And empiricism?
Empiricism is about observation and measurement. It's about the data. What do experiments actually show? In science, especially experimental science like exercise phys, empiricism is ultimately the decider.
Can you give an example?
BCAAs are a great one. Branch chain amino acids. Logically, you could argue they should help muscle growth, right? They're involved in protein synthesis. They might reduce breakdown.
Yeah, sounds reasonable.
But when you actually test empirically, study after study shows taking extra BCAAs doesn't really help people build more muscle compared to just getting enough total protein.
So the logic seemed sound, but the data didn't support it.
Exactly. And that's where pseudoscience often lives in plausible-sounding logical arguments, while ignoring or dismissing the direct evidence. Empiricism forces us to confront reality.
So the takeaway is, trust the data, even if it contradicts a logical theory.
Pretty much. Rationalism is great for generating hypotheses, ideas to test. But empiricism is what confirms or refutes them. Is how our understanding evolves, sometimes slowly, piece by piece, based on evidence, rather than sticking rigidly to a logical conclusion that the data doesn't back up.
Okay, applying that empirical lens then. Let's go back to the high volume arguments. What about that common counter argument? Oh, the extra size you see from high volume, it's just temporary swelling, it's edema, it's not real muscle.
Right, that's a classic rationalist-sounding dismissal. But what does the data say?
Yeah, what does it say?
Well, muscle swelling does happen right after a workout, sure, especially if it's new or unusually hard. But studies show it decreases pretty rapidly as you adapt.
How rapidly?
Within, say, 24 to 72 hours, it's largely resolved. We have recent studies confirming this. Even with really brutal, eccentric training protocols, untrained people adapt pretty quickly, maybe within 8 weeks or so. All the markers of damage and inflammation go way down.
Okay, so the swelling effect is mostly short-term, especially once you're adapted.
Yes, and here's the really crucial empirical point. The effect of training volume on hypertrophy, actual muscle growth, becomes more obvious in longer studies.
Well, longer studies, right?
If swelling was the main reason high volume looked better, you'd expect the opposite, right? You'd expect the difference to be biggest in short studies before the swelling resolves or people adapt.
Ah, good point. But we see the opposite.
Exactly. The fact that the benefit of higher volume is clearer over longer durations strongly suggests it's causing actual tissue growth, not just temporary puffiness. The empiricism refutes the "it's just swelling" argument.
Okay, makes sense. What about the other related idea, sarcoplasmic hypertrophy? Is that just fake muscle or puffiness too?
Yeah, it often gets lumped in with swelling.
Mm.
Sarcoplasmic hypertrophy is the idea that the non-contractile parts of the muscle fiber, the fluid, glycogen, mitochondria, etc., increase disproportionately compared to the contractile proteins.
So bigger fibers, but not necessarily proportionally stronger.
That's the idea. The sort of strongest indirect evidence for this came from a study back in 2015. It suggested bodybuilders had muscle fibers that produced less force for their size,
Okay.
but that study has largely been refuted. A follow-up study in 2021 found some methodological issues with the original research.
Oh, like what?
It seems the apparent difference in force production was likely an artifact. Basically, the fibers were swelling up during the measurement process itself, making them look bigger and weaker than they really were.
Ah, so a technical issue with how they measured it.
Exactly. So our understanding of sarcoplasmic hypertrophy as a distinct major phenomena, it's still pretty fuzzy, honestly.
So we don't really know if it's a big factor?
We don't. There are hypotheses. Maybe it's temporary. Maybe it happens before myofibrillar growth kicks in. Maybe it happens only when fibers get really big. But it's also incredibly hard to measure accurately. Think about it.
Yeah.
Muscle biopsies take a tiny, tiny sample. Trying to precisely measure the proportion of contractile versus non-contractile stuff in that tiny sample and then extrapolate to the whole muscle. It's really challenging.
So it's just sarcoplasmic argument doesn't have super strong evidence behind it either.
Not really strong direct evidence, no. The bulk of the evidence still points towards higher volumes, leading to more actual contractile tissue growth over time.
Okay, so bringing this back to practical advice. Based on the data we do have, where does the evidence seem solid in terms of weekly sets? Is there a number we can feel confident about?
Yeah, looking at where the data is reasonably dense, we can be pretty confident recommending up to around, say, 25 sets per muscle group per week.
25 sets. Okay.
Beyond that point, the studies become much fewer and farther between, so our confidence level in making recommendations naturally drops off.
Right. But what about the upper limit? You mentioned studies going up to 45 sets still showing benefits. Is there any evidence for that inverted U where doing too much actually makes you grow less? Has any study found that yet?
That's the million-dollar question, isn't it? The honest answer is, we don't have clear evidence for that downturn yet.
Really? Not even at 45 sets?
The studies pushing those high volumes, like 30, 40, 45 sets, they still generally show more growth compared to lower volumes. Now, theoretically, that inverted U should exist, right? You can't just add sets infinitely.
Yeah, eventually you'd just break down.
Exactly. But based purely on the hypertrophy data published so far, we haven't clearly identified that peak and downturn. Maybe the next study will find it, but for now, the limit seems to be higher than previously thought, certainly higher than that old 10-20 set idea.
Speaking of that 10-20 sets, where did that recommendation even come from? It feels like it was everywhere for a while.
It really was. But it was never based on super strong direct evidence showing that's the optimal range. It seems to have stemmed from maybe a bit of a lazy interpretation, as some have called it, of a 2017 meta-analysis.
How so?
That analysis basically just lumped everything above 9 or 10 sets into one single high-volume category. Didn't really differentiate between 12 sets, 20 sets, or 30 sets.
Ah, so it just showed more than 10 is better than less than 10, but not how much more is better.
Pretty much. And critically, during that period, there were a couple influential studies that did seem to support lower volumes, like maybe 5-10 sets being optimal.
Okay.
But those studies were later retracted because the data was found to be fabricated.
Wow, seriously?
Yeah.
Fabricated data?
Yeah. And the time between when those studies were published and when they were retracted definitely skewed the perception and contributed heavily to that 10-20 sets is probably enough consensus. Remove those faulty studies and the picture looks quite different.
Okay, that context is really important. But let's talk feasibility. Doing, say, 30-plus sets per muscle group for all your muscle groups. That sounds like living in the gym. Is that even realistic?
It's definitely a significant commitment, no doubt about it. When you look at surveys of competitive bodybuilders, you do see some reporting volumes in that 30-40 set range per muscle group per week.
Some do it, okay.
But it's not the norm. The typical range reported is usually more like 12 to 24 sets. And the research we have doesn't strongly suggest high volumes only work if you focus on one or two muscles. Studies often have participants train multiple muscle groups with high volumes and see benefits across the board.
But the downsides?
Time, obviously. It takes a lot longer. And importantly, a higher risk of joint aches, tendon issues, that sort of thing, especially if you jump into it too quickly.
So slow and steady ramp up is key if you try it.
Absolutely crucial. We're talking gradually increasing over maybe 3 to 6 months, not trying to double your volume overnight. Your connective tissues need time to adapt.
You mentioned earlier that not everyone responds the same way, though. Can you elaborate on that? Why might higher volumes work wonders for one person but not another?
Right. Individual response is huge here. While on average, higher volume leads to more growth, the spread is wide. You might have roughly a quarter of people who respond dramatically better to high volume.
Okay.
Maybe another quarter see a moderate improvement. Another quarter might see no real difference compared to moderate volume. And then maybe another quarter actually do better on lower volumes.
A quarter doing better on lower. Interesting. Why the difference?
We don't know for sure, but there are potential reasons. Genetics play a role, obviously. Differences in things like ribosome biogenesis, how quickly your cells can build proteins. Satellite cell activation, those are muscle stem cells involved in repair and growth. Fiber type distribution could matter too. People with more fatigue-resistant type I fibers might tolerate and benefit more from higher volumes.
Type I, the endurance fibers.
Yeah, but they still grow quite a bit. And then there's the real-world factor, effort. In a controlled study, people might be pushed harder than they typically push themselves in their regular training. Maybe some people just don't maintain the necessary intensity when volume gets really high on their own.
That makes sense. So genetics, fiber type, maybe even just practical effort levels. Given that high volumes can work, at least on average, why don't we see more people doing like 40-plus sets routinely in gyms everywhere, besides the time factor you mentioned?
Time is probably the biggest practical barrier, let's be real. Getting maybe 20% better results, but spending 50% more time in the gym, that trade-off isn't worth it for most people who aren't competitive bodybuilders.
Yeah, the diminishing returns hit practicality hard.
Exactly. And there might also be a systemic recovery issue. Even if each individual muscle could handle more, maybe your overall system, nervous system, endocrine system, joints, hits a recovery bottleneck when you try to push everything super hard simultaneously.
Like a total body stress limit.
Potentially, yeah.
Yeah.
It's easier to blast one or two body parts with insane volume than it is to do it for everything all at once, week after week.
Okay, another question. These studies are often, 8, 10, 12 weeks long? They might show, say, 10% more growth with high volume in that time. Can we just extrapolate that out? Like, does that mean you'll gain 10% more muscle every 3 months indefinitely if you stick with high volume?
No, definitely not. Muscle growth isn't linear like that. It follows more of a logarithmic curve.
Meaning it slows down over time.
Exactly. Your gains are fastest when you're starting out or recovering lost muscle, and they slow down progressively as you get closer to your genetic potential. Higher volume seems to lead to faster gains, especially early on.
So you get more growth sooner?
Yes, and likely more total growth over, say, the first year or two compared to lower volumes.
Yeah.
But it's possible that over a very long time frame, like 5 or 10 years, the total amount of muscle gain between someone doing moderate volume versus high volume might start to converge somewhat as they both approach their genetic ceiling.
Interesting. But very low volume would still be lagging behind.
Oh yeah, very low volumes, like just a few sets per week, are almost certainly suboptimal for maximizing long-term growth for most people.
What about volume cycling? You hear about people increasing volume for a while, then backing off to resensitize, then pushing up again. Is there anything to that?
That's an interesting theory. The idea is based on progressive overload that you need continuously increasing stress. So maybe constantly pushing high volume leads to accommodation, but cycling it allows you to keep adapting.
Does the evidence support it?
There's some indirect physiological rationale, maybe some suggestive findings, but no really definitive studies validating volume cycling as superior to just maintaining a consistently appropriate volume yet. However, even if cycling turns out to be beneficial, the principle likely still holds. Training with generally higher volumes, even if you cycle them down periodically, seems to be more effective than training with consistently low volumes.
So the baseline average volume still matters.
It seems to.
Okay, let's revisit the mechanism. At the most basic level, how does doing more sets lead to more muscle? Is it just more stimulus, more growth?
That's the simplest and likely largely correct answer. A greater total stimulus triggers a greater adaptive response, up to a point.
Is there any more nuance to it?
Potentially. One idea relates back to fiber types. Higher volumes, often involving more reps and maybe shorter rests, might be better at stimulating those fatigue-resistant type I fibers.
Which you said contribute significantly to overall size.
They really do. They might be underestimated in traditional strength training. Also, think about the bioenergetics, the energy systems within the muscle. Things like capillary density, more blood supply, and mitochondrial function, energy production, are crucial for supporting muscle growth. Higher volumes might promote these adaptations more effectively, removing potential metabolic roadblocks to fibers getting bigger.
So it's not just triggering the growth signal, but also building the support systems needed for that growth.
That could definitely be part of the picture, yeah.
We talked about strength versus size earlier. How good is tracking your strength gains as an indicator whether you're actually gaining muscle, especially in these shorter time frames like a typical study?
It's tricky over the long term. For a specific individual who is already trained and consistent with their technique, tracking strengths can be a reasonably good proxy for hypertrophy. If your lifts are consistently going up over months and years, you're probably gaining muscle.
Okay, long term it works better.
But in the short term, like those 8-12-week studies, strength is often a poor indicator.
Why?
Because, as we discussed, those early strength gains are so heavily dominated by neural adaptations, just getting better at the lift. The point where hypertrophy becomes the main driver of strength increases is probably around that 8-12-week mark, or even later for some exercises.
Right when the study often ends.
Exactly.
Yeah.
Plus, in smaller studies, you get more random variation sampling variance. One small study might show strength going up without much size gain. Another might show the opposite, just due to chance or measurement error, even if the underlying relationship across many studies is clearer.
So don't put too much stock in week-to-week strength changes as proof of muscle gain, especially early on.
Generally, no.
Yeah.
Look at longer trends.
Let's talk about diminishing returns again. You said higher volume leads to more growth, but with diminishing returns. Can you clarify what that means? Does diminishing returns mean it's not worth doing?
That's a common misunderstanding. Diminishing returns just means each additional unit of input gives you less output than the previous one.
Okay.
So maybe going from 5 to 10 sets gives you X amount of growth. Going from 10 to 15 sets gives you less than X, maybe 0.7X. Going from 15 to 20 gives you even less, maybe 0.5X.
Right, the benefit per set decreases.
Yes. But importantly, diminishing returns does not mean lower total returns. In that example, 20 sets still gave you more total growth, X plus 0.7X plus 0.5X, than 10 sets, just X.
Ah, okay. So even though the efficiency per set goes down, the total result can still go up.
Exactly. So the goal of maximizing efficiency, most growth per set, often favoring lower volumes, and the goal of maximizing total results, most growth overall, often requiring higher volumes, can be contradictory.
And people need to decide which goal is more important to them, considering the trade-offs.
Precisely. Time, effort, injury risk, recovery capacity, all need to be weighed against how much growth you're aiming for.
Okay, so let's try to synthesize all this. What's the practical recommendation for someone listening? How should they figure out their ideal volume?
Well, first things first. If what you're currently doing is working, if you're consistently making progress, you're happy with, don't change anything.
Don't fix what ain't broke.
Exactly. A bird in the hand is worth two in the bush. Don't mess with success just because some studies suggest something else might be slightly more optimal on average.
Good advice. But what if you have plateaued? Or you feel like your progress is way slower than you'd like?
Then, Based on everything we've discussed, increasing your training volume is a very valid evidence-based strategy to try.
How should someone approach that? Just double their sets next week?
Definitely not. Gradual increase is key. A reasonable starting point might be to aim for about a 20% increase in weekly sets for a target muscle group.
20%, okay. And then what?
Stick with that for maybe 2-4 weeks, see how recovery feels, then maybe add another 20% if things are going well. Do this gradually over, say, 2-3 months.
And how do you know if it's working?
Monitor your progress objectively. Are your training loads, weight on the bar for the same reps, starting to consistently exceed what you were doing before on the original lower volume? That's a great sign you're responding well.
So getting stronger on the higher volume is key.
Yes. If your loads are just staying the same despite doing more sets, that's kind of a neutral signal. You're building work capacity, maybe some endurance, but perhaps not driving maximal hypertrophy effectively. And if your training loads actually start to decrease and stay lower after a couple months on a higher volume,
That's a bad sign.
that's a pretty strong sign that that level of volume isn't productive for you right now, and you should probably back off or explore other strategies like changing exercises, improving nutrition, or focusing on recovery.
What about those specialization blocks you mentioned?
Yeah, focusing high volume on just 1 or 2 muscle groups for a period while maintaining lower volume elsewhere can be a great way to test your individual response. It gives you a clearer signal because you're not trying to push everything at once.
Well, it's about finding your sweet spot through careful experimentation.
Exactly. The goal isn't necessarily to hit some magic number like 25 sets or to do the absolute maximum volume you can possibly tolerate. The goal is finding the amount of volume that you need to stimulate the progress you want, balancing results with recovery, time, and enjoyment. Individual context is everything.
Wow, okay, we really went deep today. We unpacked why those old assumptions about strength plateaus limiting muscle growth don't really hold up when you look closely at the data, especially for trained individuals.
Yeah, we saw that higher volumes generally do lead to more growth and, importantly, more strength gains, too, contrary to some interpretations.
And we touched on the role of connective tissue, that strength isn't just muscle fiber size, and the importance of relying on empirical data over just logical arguments.
Definitely. Trusting the data, even when it's complex or contradicts old beliefs, is key.
So this whole exploration, it's more than just how many sets should I do. It's really about thinking critically, right? Applying these scientific principles to your own training journey.
Absolutely. And maybe it prompts a question for you, the listener. If your goal is to optimize your progress, what aspects of your current routine are you just taking for granted based on old assumptions?
Yeah, what new possibilities might open up if you looked at your training with this fresh evidence-based perspective we've discussed today? Something to think about.
Keep exploring, keep questioning, keep learning.
Couldn't have said it better myself. Thanks for joining us on The Deep Dive.